So, okay, let's start. So, my name is Shiv. I'm the CTO of a startup in Delhi from India called Indicus, and we started off in 2013. And my Cloudstack journey has been more or less from 2013 only. So, I'm going to talk about monitoring and how, what are the nuances and what all you can monitor on a Cloudstack implementation. But just a brief about my Cloudstack journey. So I'll give you background. So I was primarily a C and Perl guy, software developer all these years, and from 2013 when we started, this whole concept was introduced to me, the cloud, and had dabbled about a little bit in virtualization, but not much. So, man, when I saw it, I said, what am I getting to? But over time, after spending a lot of time there, I realized that yes, Cloudstack works. It was quite intriguing for me. And 6 years down the line, we can call ourselves as a power user. And we do a lot of things, not on the dev side per se, but on the admin side of Cloudstack, we do a lot of interesting things. So, what I'm going to talk about is primarily on the monitoring aspects of Cloudstack based on my experiences. And I've tried to keep the content generic and not specific to any particular, monitoring software like an Nagios or a Zabbix. While we do use Zabbix, I've tried to keep it neutral. And what I want to highlight is what all challenges we face, what all things we monitor, and how we overcome them, right? So before I proceed, I'd like to make a disclaimer that there may be some methods I'll be showing you or talking about which may be very appalling as to, things like dipping into the Cloudstack database for some stuff, etc. But yes, we do that. Okay. So I'll be covering primarily the monitoring activities, the basics, the application. Then it goes on getting more and more interesting. Then we go to the cloud resources. Then how certain set of automated processes can, help further fine tune and keep a control on the Cloudstack installation. And finally, auto-resolving some common issues. Again, auto-resolving needs to be taken with due consideration. It may not be suitable for all deployments. It may be suitable for some deployments. Again, within that, there may be certain things which can be easily done without any harm, and certain which may need further evaluation and may need to stop at a notification. I'll just dwell on those. And all this monitoring can be done in a straightforward way like all monitoring software does. But we also need to look at how the data is being monitored and where it is being monitored from. We call that this access perspective. So I'll be dwelling on what is an access perspective and what we monitor there and how we monitor that. After I cover the basics, we'll reach there. So let's go to the main monitoring activities. Right. So these are the activities one needs to do for monitoring any application, be it Cloudstack, be it whatever be your application. Primarily, there's a bit of discovery, there's a bit of collection, there's representation and reporting that you need to do, then there's a bit of correlation, and then there is analysis and planning, and which constitute your capacity management, etc. And then there are actions which you need to do based on certain events or anomalies occurring, right? So let's see what we use for monitoring Cloudstack. So we use a combination of bash scripts. Bash is a awesome tool for doing all sort of stuff which cannot, which require different other tools to integrate with. So we use a lot of bash scripts. We use the monitoring agent. Typically we use Zabbix, but any agent can be used. Then a lot of command line tools. We use a lot of command line tools for monitoring. ACS API, needless to say, is being used. CloudMonkey, it's an excellent tool for getting immediate command line and programmatic values from the Cloudstack implementation. And we also do SQL, as in we have a read-only user which dips into the cloud and cloud usage database for some metrics, right? So the caveat here is when one migrates from a version A to A plus or some other version, then one does need to take care of schema changes, content changes, etc. Okay. So from a discovery perspective, most monitoring software will allow you to have auto discovery. So things like zones, etc. can anyway be discovered by calling the API and getting a list zones and seeing what is there or not. So what I'm trying to emphasize here is what we noticed is there is not one single tool that can help you do everything. That's why we use a lot of bash to take data, whether it be it discovery data, be it collection data, and then validate them and then decide what to do. So for example, hosts, we use Zen server for our installations. So in Zen server, Cloudstack typically talks to the Zen server via SSH. So we also use that same concept. So for discovering hosts, what we do is we directly dip into the DB and get the host newly created based on the current time. Instead of doing a list host, checking what I have, or maybe iterating through that and get the create time, we do it through the SQL and it works for us. So while it may not be the best way to do things, it does work for us. Similarly for clusters and system VMs, in the case of system VMs, I'll cover that at a later slide, but what I want to emphasize is we are not interested in as of now in monitoring the CPU, etc. of the system VMs. So for example, if a system VM is destroyed and it's placed elsewhere and the name also changes, it doesn't matter to us because we are monitoring more on the system VM's stability aspects rather than keeping a track of how it has performed over time, right? So the same goes for a VR, because these three type of virtual machines are such that they can be destroyed and can have completely different identities from a perspective of integrating through programmatically. So we do not try to monitor them on and keep records for a long period. Then we collect data using all these tools from Zen, from system VMs, from OS, at the OS level, the DB, logs, etc. Then again, representing and reporting, we use graphs, Excels, reports, and SLA. There's something unique we do, which is called the Z-axis. So what this does is, since we have data, let's say, of a particular host over time, so what we do is we not just give you the access of a period, let's say from 1 year to time 1 to time 2. We give you a method wherein there's your time 1 and there's a 24-hour slot from 00 to 23:59, and there are two lines which if you can see here, there are two lines. The green line is the current dates line and the yellow line is the average of all the 30 days for that particular time interval in the 24-hour period. So we use this to evaluate a lot of patterns as to how the host is behaving over time. Then we do a lot of profiling. I'll come to that later. Profiling basically means, based on SQL queries, you can actually find out what is the time that each job, let's say a VM create, took, right? So based on that, you get to know what job is taking maximum time, and all that is easily available from the database instead of having complex log analyzers. The beauty of Cloudstack events and the notification is that you can do that at the database level itself. So based on that, you can do a lot of trends. For example, which VM of mine, from a service provider perspective, which VM of mine is selling most, which VM is not selling much. All those analytics can come in from this place. Then from a resolution perspective, of course, you can have alerting, and it is a must. You can have logging. You can have actions wherein you can feed to external systems. For example, in a service provider scenario, suppose you have a Cloudstack setup and you have a VM which is created, but their billing guys say that whenever a VM gets created, boss, you need to tell me, or maybe shove it to my message bus or something like that, So all those things can be done using auto resolution or using actions. So this is a very quick slide. I am not getting into this much. These are the general metrics that are typically required to be monitored in any OS. The important thing is that we should also monitor the ports from a TCP/IP perspective, whether they are working or not, and not just the processes but the ports as well. You can take that even further. For example, in the port of 443 or 8080, you need to get back a particular text. You can take it as further as deep as you want. Then we come to the application metrics. Here we use socket commands, typically like netcat, etc. And then we also have we validate for content that is coming back as a response, and of course standard SSH and CLI. So these are typically, if you see, the first two are just to capture whether the processes are running or not correctly. And the second one, the third one is sort of a command to check if the cloud, you do have a system VM agent. You can always query from that, but this is an added check wherein you can go via the hypervisor into the system VM agent and check for status of clouds, or you can run, let's say, ssvm check.sh and gather the output. The first step that you do when a system VM fails is you typically go into the system VM and do the ssvm check. So that can also be further automated, and we can take it further. Again, when you hit Cloudstack and get back a response from the UI perspective as to ensure whether the UI is working, you can verify for 200 OK, or you can even go and force a login, username, password login through the UI programmatically, get the response and see if the notification letter is coming. So there's no end to how deep you can go. This is just an idea of how we do stuff and what all can be done. Tomcat, again, we use the JMX mode. So these are general Tomcat stuff that we monitor, and stuff for Tomcats, OS, etc., MySQL. There are a plethora of templates available all over the net for all kind of monitoring software. So I'm not getting into that. So that's a very easy task that can be accomplished. In MySQL, typically we would like to see the slow query log and the slave status. Again, for MySQL, there are n number of parameters that can be monitored right from your InnoDB buffers and your write cache hits, the ratio, etc. So I've kept that out because it's not really pertaining to Cloudstack per se. Then we use HA proxy for load balancing between multiple Cloudstack management servers. So from from monitoring the HA proxy perspective, again the HA proxy is also in a pair that's installed. So we need to definitely look at a couple of parameters: the request rate, the rate at which the responses are being served. Then from the backend type of metrics, you require the queue concurrency, the queue time, and the service time, etc. Then from HA proxy perspective, file descriptors and allowed descriptors and the difference between them is something that we would definitely like to see. Logs, again, you can take this with a pinch of salt. We can go as deep as we want in monitoring the logs, and we can decide only to monitor errors. But yes, it is possible to monitor logs also. And what we just need to do is, take a grep of all the lines which have error in it, and see that it has not increased more than the previous poll. So suppose the first poll says there are 15 errors, and the second one also gives you the 15, then there has been no error between the two polls. But suppose it does give you an error where your word count, WC is basically your word count, my -l gives you the lines. So it can give you the number of errors on all the logs that have occurred recently after your previous poll. Okay. Now, from a cloud metrics perspective, we primarily do Zen server only. So most of my examples here would be about Zen server. So traditional DOM 0 stats are something which we need to monitor and store and calculate. Then again, Zen server's reachability to ACS is something which we would want to do. Regarding the host metrics itself from Zen server, that is a really difficult task to achieve, because Zen server doesn't give you, even if you install the agent or if you poll the SSH of Zen server, it typically gives you the value only of DOM 0. So what you need to do for that is, you need to go into ZenTop and parse that and obtain values for even a simple thing like CPU utilization. And again, that comes on a per CPU basis, which needs to be aggregated. So Zen server host monitoring is a little tricky, but we have been able to obtain the CPUs utilized based on that. Okay, and again, this is we use NFS for storage. So typically, what happens is we need to know upfront and beforehand if there are any stale NFS storage mounts on the Zen server. So we achieve that by doing an SSH. All this is via the NMS software. So we can use either keys or we can use the password of the hypervisor and run our own set of commands. So even my probes, even the probes that we do and the collections is more of a custom script. There are a lot of CPU etc. can come as inbuilt as part of the agent templates, but we do a lot of custom scripts to pull the data and all. So basically what this does is we just need to see that this doesn't give any output. This means that none of the SRs are stale and everything is hunky-dory. So from traditional cloud metrics, we do IP allocated. These are all actually available from the Cloudstack API itself. In addition, as I said, I've put a star on hosts. That basically means that for hosts, we need to do a lot of additional stuff at our end, especially in the Zen server level. And at the host level, we can do additional checks on the status of the NICs and the RAID of the host disks. That is where the host OS, the Zen server itself resides. Then on system VMs, we can check for the reachability, the agent status, and the availability of 3922 port, which is used for local communication with the underlying hypervisor. Again, from a capacity perspective, we do a lot of storage backend and IP checks, VLANs, etc. These are all standard checks that mostly can be done using Cloudstack APIs. Okay, now I'll come to this the usage server. So typically when you're running Cloudstack in an ISP environment, the billing happens on an hourly basis. So we definitely need to get usage on an hourly basis, right? So we have to ensure that the usage server is running. This can be done by a process check or by DB values that can be done. Again, deployment planner efficacy. So we can get all the hosts of a cluster. What we do is we get the hosts, all the hosts of a particular cluster, and using the VM and its offering versus the host offering, host capacity, we can get a spread of all the VMs in a host and see if there is any one particular host or something which is very skewed or not. This again, once the host metrics are there, we need to store those host metrics. What we do is using that Zentop, we take those metrics, store it in the Zabbix DB stores it. Then based on that, we have an external check which basically dips into the monitoring DB itself, takes the data and sees if there is any skew. So we again use standard MySQL variance and standard deviation commands to obtain that. Now in a service provider scenario, there's another thing we do called tagging of hosts. So why we do that is typically to save money, especially on licensing. We tag, let's say, 3 hosts for Windows and others for all other generic workloads. So that way the reporting of all Windows virtual machines, etc., you need to have only 3 hosts and your licenses can be applied at the host level. So in that case, what happens is whenever we deploy a particular VM of, let's say, Windows offering, so we tag that offering and force it to go on that host. So when we are doing a capacity check or when we are doing a check for ensuring that the deployment can be successful, we need to consider the tags of the host and consider those hosts in isolation when monitoring capacity. Okay. Then coming to offering checks. So whenever a new offering is created, again by dipping into the database, one can get to know which is the latest offering that has been created. And Cloudstack, while creating the offering, will happily allow you to create whatever gigahertz you want, irrespective of what is there on the underlying Zen server. So what one needs to do is, we have our rules. For example, in Zen server, more than 16 cores is not supported. So we have those checks in place, like if a new offering is created, it should not be more than 16 cores. The gigahertz cannot be more than what is the gigahertz of the underlying hosts, etc. Coming to virtual routers, we have seen cases where when you add a private gateway to a virtual router, then there are some issues in the static routes which do not come up on a reboot. So using the same, I'll come to this again. Using the same logic of going via the hypervisor and into the VR, one can find out if there are any missing static routes. Okay. Then coming to management server load, we can check the load of the management server, how many requests each management server has received and how it is being balanced. This can be done by HAProxy logs itself. We can also tap into the events and alerts. Again, this can be tapped at the DB level of Cloudstack, and we can obtain data at the events and alerts level. We just spoke about profiling, what type of VM is selling, which is my best offering, etc. So we can do all that. Then coming to process metrics. So these are, now we have more or less covered the installation part. Now we are trying to see how things are when they are running. So typically we'd like to do this maybe once in 6 hours, where we create an account, we create a VPC and a VR and provision a VM inside that and create tiers and check whether it's running, and then destroy the same. So basically what this does is it takes care of the complete, more or less the complete flow that any typical use case will require, right? From a monitoring perspective, we also need to monitor that our backups, that is the backups of the Cloud DB and the backups of the cloud usage are happening on time. So we can use that also as part of monitoring. Now let me come to the access perspective. So are the colors visible? Okay, so if you see here, the management communicates through this management traffic with all the hypervisors, right? So let's just remember that for a moment. This is a slide outside taken from the Cloudstack documentation itself. So it's available on public. Now let's keep that in mind and look at this slide. This was again presented by Chiradeep in 2013. But what I want to highlight here is, in case you're using PV-LAN and a monitoring server which is going via the PV-LAN, there can be a situation where your host, or let's say your MySQL DB or your Cloudstack management can give you a status of, can give you a positive status or a healthy status, but the connection between the two is not healthy. So we need to actually monitor where we are accessing the same data from. For example, if we are accessing a latency of, let us say, the Cloud DB, the latency of the Cloud DB from the monitoring software can easily be obtained by any monitoring system, but we are not really interested in that. What we are really interested in is the access between the host and the Cloud DB, right? So for that, these are the specific cases that we monitor. The management server to Cloud DB, then again between management servers, how they communicate with each other. That is something again we need to check. Then the HA proxy to management server, we have to ensure that that pipe is also successful. So all these you cannot really do directly from the monitoring system. So for these, what we do is from the source host or the source device, we run external custom scripts that will go and simulate as if the device itself is doing that activity and obtain data and get it back. Then again, management server to Zen is typically via shell and Zappy. Then reverse also is true. The access to 8250 from Zen server is also something that needs to be monitored. Then in an SSVM, while we do have a check for that check ssvm.sh, but primarily what we need to see is that the SSVM is connectable to the internet via ETH2, to management via ETH1, and in case there is a separate storage network, it needs to be connected via ETH3. Then the same goes for CPVM and internet, CPVM to management server and the internet. Now let's come to auto resolving. Okay, so there's a disclaimer. We need to be really careful in running these. It does work, but we need to exercise prudence as to what to use, when to use, and in which scenarios to use. Okay, so in this I'll be giving a lot of examples and code snippets. So typically an agent failure in SSVM and CPVM, what we need to do is we have the metric of SSVM check. So what we do is we, via the underlying host, when you define this metric in a monitoring provider, monitoring service, you define it as a metric of the host, not as of the metric of the target. So as a metric of the host, you go into the host and use the same keys that the host is using to log into the CPVM or SSVM, run the command, get the output, and feed the data back to the monitoring system, right? So the mode that we use for this is a combination of SQL, SSH, CloudMonkey. This is the metric and this is the method to obtain the data. For resolving this, first, actually this SQL is to obtain the link local IP and the host IP of any SSVM. So typically this is already there with us, because that is how we have added that SSVM into the monitoring state. But this is the query to get that data from the underlying DB. Once this is done, there are a couple of ways of doing this. In Zen server, under opt cloud bin, there is a router proxy.sh, which is basically used by Cloudstack to send any command to the router, to the system VM, be it router or CPVM or SSVM. And while the command that you want to run needs to be under opt cloud bin, there is no validation there, so you can easily, escape it, go back and run whatever command you want, and it can automatically restart the cloud services on SSVM. If you don't want to do that, you can anyway use the default keys that are there in the underlying hypervisor, or you can use CloudMonkey. Now what happens is, Fine, this has restarted it once, but what happens if the problem persists? So what we do is, in this case, this is the first attempt of resolution. In case there is a second trigger for resolution and we have already attempted this, then it's just a notification which says, boss, some manual intervention is required, right? Then we have faced some issues with the sync queue having going close to 2 or nearing 1 or even crossing 2. So in this case we monitor using sync queue. Resolution is pretty simple, but we need to be careful in this resolution because the jobs that are running can be jeopardized by running Cloudstack management. So what we do for this is, in our labs, in our dev labs, we have a lot of people doing a lot of activity, so this happens quite frequently. So in our labs, we are more than happy to attempt and do this service Cloudstack management restart and in a DevOps environment, but probably it's not advisable to do it in a service provider environment. Okay, then this again is something which is very, very critical to service providers. Your usage server has to be running, and because if you are doing a rating on hourly basis and that too on a prepaid model wherein the customer has already paid his money, so it has to be deducted and you're not going to send him a bill. For that, it is very crucial for the usage server to be running, right? So just ensuring that a PS-EF usage server is running may not suffice. So what we do is we need to get the end date from the cloud usage so that at least one entry is happening. We know that usage has occurred, right? And in case it has not occurred, we do a usage restart. And if the problem happens again, that is, if it is recurring even after this action, we have to go to the alert and manual way of trying to solve it. Okay, so in the virtual router, service providers, so I'm sorry, we have a lot of deployments from on a service provider perspective, so much of my talk is from that side. But from a service provider perspective, they like to offer various flavors of a VR. Let's say like 2 core, 2 gig VR, maybe a 1 gig, 1 core VR, and maybe a 1 core 512 MB VR, right? So there are different offerings that are created for the virtual router. Now, all this is fine, but the first thing that happens when by chance the customer presses the cleanup and a restart is that this offering is totally ignored, right? So even while creating the virtual router, when you create the virtual router for the first time, and even though their API call does support providing the offering name, it by default only creates it in the default offering. Then we have to manually stop the router, change the system VM offering, and restart the router. When you do this programmatically. So in this case, what happens? As soon as the router there's a cleanup and reboot, it will go back to the same default offering, which may not be what the service provider has promised or entered into a contract with the end customer. So let's assume that my offering is called something, let's say it starts with IN, right? So if I see any domain router which is running and which doesn't have the service offering name like IN, we can also do this. We have done this on name. One can also use tags and do this. So as soon as we see this, we need to send an alert to the administrator in case of a service provider that this has been there is an anomaly detected. So the solution is very simple. We just need to stop it and restart it. But then again, this cannot be done on a service provider perspective. This can be done in your, if you do a lot of, test on your local lab and you require a heavy throughput router, this can be done there. But on a service provider perspective, it's better to alert. However, the solution is to just stop the router, change the service offering for the router to what you want and restart it. Right? Okay. Then coming to VR placement. So again, from a service provider perspective, storage can be offered in many tiers, right? There will be SSD storage, there will be NLSAS and SAS storage, and you can have layered storage. And typically those storage have tags, like, right? You have a tag called SAS, you have a tag called SSD. And when you create the offering for the virtual router also, there is a concept of specifying tags. But when you deploy the virtual router, it does not consider those tags at all, and it totally ignores it and goes and sits on the first available storage device. Now, while that is fine, there are some cases where we have seen that, especially if it goes and reaches on an LLSAS and the IOPS are not available for the particular router, then it goes into a stale state. Most of the issues happen because the router doesn't get the required IOPS from the underlying storage and goes into a stale state. So this is the metric to obtain that, and to resolve this, you can just live migrate it to the storage which you want. That is basically to an SSD storage or wherever you want, right? Then, as I said, this is a different side of the same problem. VR can have read-only mounts, especially if it's running on NFS, and that while normal operations may not be affected, but whenever you try to do any activity which requires the VR to write to the local disk or anything like that, then it goes into failure mode and stale mode. So we can just obtain periodically a count of all the read-only mounts on the VR, and if we find a mount where it shows as it's a read-only mount, then we can try to solve it by restarting the router. So again, this is not for service providers. It will be more for labs or maybe enterprises. Even if you don't do this, this is the end solution, but probably you would want to do this after consulting and informing the end customer. Because bringing the NFS back without restarting the router, I'm not aware whether such a thing is possible or not. So this is the only way to do it, but then from a service provider perspective, you may want to talk to the customer and get it done first. Right? Okay. Then coming to another use case, there are situations where your VM is in expunging state in the database, but not completely destroyed. So what this query does is basically it gets a detail of what all is how many VMs are in expunging state, which are in expunging state for more than 2 days. Typically, the cleanup interval after destroying a VM is kept to 86,400, which works out to 1 day. So we've kept it as 2 days. Again, this can be tweaked as in how you would want your check to be. Once this is done, you are able to identify that, okay, these are the set of VMs which are in expunging mode, which have not gone to destroyed. Now, that's not enough. We need a further validation for this, because there may be cases where it is expunging, but Zen has So what will happen is it will be put as expunging, but the Zen may not have failed to delete it, may have failed to delete it, or may have successfully deleted it, but the communication may have not been passed on to Cloudstack. So what we need to do is we have the we have the ID from this. We need to check in the Zen whether this VDI exists or not. And only if it doesn't exist can we take the resolution path. If it does exist, we have to take the alert path. So once the VDI, we are sure that the VDI is out, then all we need to do is set some flags on the ACS DB, and that can be solved. So basically we'll set the flags on the volume, and we'll set the flags on the VM instance table and bring the thing to normal. So what next? What are we doing next towards on this front? We already have an auto scale product of ours which works outside of Cloudstack. So how we will be trying to enhance that and see how it can fit into Cloudstack natively, or at least it works more seamlessly with Cloudstack. So right now what we do is we have our we have VMs and we have agents installed in the VMs as part of the template offerings, and based on that we are able to collect metrics, and the person is able to specify that okay, if both these VMs have a CPU more than 70% for continuously 15 minutes, add a third one. So what happens is the third one is placed under the same VPC, under the same tier, under the same LB with all the rules in place. Then again, the rollback can also be specified by the end user where the person says that okay, now when all these three go below 50 for continuously 15 minutes, kick out that old VM. So that's something we are already doing, but we're trying to see if we can develop this. So that's a totally outside-in integration with Cloudstack, but we are trying to see if we can make it more closer. And we would like to contribute an extensive plugin on these monitoring aspects. Typically we use Zabbix, so we would want to do that first. But I had a chat with Alexander also, who had presented the monitoring, another monitoring discussion. CheckMK. So probably we could align our thoughts together and make it into a single agnostic kind of a template. We would like to do a lot of VR checks, which we are not doing right now. For example, my NAT tables, my current connected sessions. These are some things which are very, very critical to any person who owns the VR. So what happens is, while I as a customer or as a user of Cloudstack own the VR, I really don't own it. While I can create it, there's not much I can do except configure it. The feedback that I get from the reports and feedback is very, very limited. So that is something which we will really be doing now. Whether that will conform to Apache Cloudstack's vision and whether it should be done that way, that's something I can't promise, but we would be doing that. And we really loved Primate, and we've taken a spot decision that we will be helping contribute to it. So just a brief about us. We are a cloud solutions company and a product company. We help a lot of enterprises set up their private cloud, and we also have a product and we help service providers set up their public cloud. We have a marketplace product called Apiculus, which runs over and on top of Cloudstack and allows any entity to use their infrastructure and sell the cloud as a service running on top of Cloudstack. We have external integrations also with backup as a service and other software which can run on top of the cloud, but there is a centralized billing engine. Again, we've done a lot of private clouds and hybrid clouds for enterprises. We typically target telcos, cloud service providers, but we have done some stuff for airports and in the fintech industry also. And we have worked with customers in India, Nepal, Oman, Sri Lanka, Southeast Asia, a bit of Middle East and African geographies. These are references. I didn't put the URL because you can just Google and get details. These are just the image credits. Any questions?
Sure. You mentioned something about custom offerings not working in case of virtual routers. I just wanted to check, like, how are you configuring, like, for which network, what offering to be selected for virtual router?
So when we do the deploy virtual router, when we do that, we have to specify an offering.
Okay, I see. So
right.
I'll tell you another option that you can try, which is when you're creating a network offering. So at the time of creating a network offering, you can specify a custom offering for the virtual router.
Yes, but Rohit, in that I can do that. Yeah. But then I need to know that then what will be required is for each virtual router I would need to have a separate network offering, right? In a cloud service provider scenario, that's not really feasible. I would rather have a generic set of, let's say, A, B, C, D, even Z, doesn't matter, but a fixed set of VR offerings, and then whenever I create the VR, I map it to that.
Okay. So the bug we were discussing before was that Cloudstack is not honoring when you deploy the VR.
Yeah, so there is a easy solution to that. So what we do is when we deploy the VR, we use our own portal, right? So we deploy the VR, we know that it's not going to work. So as part of the main call itself, we shut it down, change the system offering and bring it up. Fine, everything is hunky-dory here. But when the customer does a cleanup, I cannot tap in there, right? If he does the cleanup from our portal, I can achieve that. But if he does a cleanup natively, then what happens is it brings up on the default offering, right? And the same goes for the storage tags as well. The underlying storage. So
basically, what you are asking for is ability to create a network, and when you are creating a network, specify what offering you would prefer for the virtual router.
Correct. And this is there in the calls.
I think it exists, like when you create a network,
it does exist.
Right. But you're saying there's a bug in it doesn't.
Yes.
Maybe
even the storage, the system we am offering for storage, it does exist. There we can specify a tag, and ideally it should, just like VM, it should go and sit in that particular storage pool or wherever that storage has that tag. But it doesn't happen. So these are maybe hacks, but that's how it's been handled. Yes. Anyone? Thank you.